Hello, everyone. Thanks for joining us today. My name is Nate Chandler Smith. I'm a senior software engineer at Integral. Thank you for joining us today to discuss test-driven development. Originally, I called this TDD 101, which is rather vague. So then I wanted to call it fundamentals. That too might be vague, but more importantly than vagary, it did fit in the slide and keep the same font size. So I ended up calling it with basics. That was the simplest thing anyway. And with what I'm going to talk about, like this is like a showcase of iterative development and keeping things simple, right? I'm going to talk about TDD. I'm going to do a test-driven development demo. I'm going to do two of them, including the Gilded Rose Cotta. So let's get started. All right, so there's three things that you're going to learn in today's webinar. You will learn the benefits of test-driven development. Tests are an integral part of TDD. So we're going to talk about how to write great tests. Then we're going to cover the process of writing code by writing failing tests first. And we will not, and then again, we will have not one, but two demos of TDD in action today. We're going live. All right, so the benefits of TDD. We'll kick it off with the benefits. It's important to understand, like, why do we do the things we do, right? Bottom line, it improves the product. It improves it improves both, really. It improves both the quality of the product and the speed at which the product will be delivered. That sounds amazing, doesn't it? It's too good to be true, you might say. Code quality improvements translate into delivery speed improvements. We'll put a pin on this and we'll come back to this soon. So how is code quality improved? In TDD, in test-driven development, you must first add a test before adding or changing a behavior or feature. This ensures high test coverage. Further, when a defect is found, a test is added to prevent regressions. This increases everyone's confidence in the code that we are delivering. Now, when practicing TDD, working code is delivered in a series of iterations, thin slices of working code. These iterations are thin in that no more code is added than needed to pass the test. In this way, the code stays lean. Lean code is easier to cover than more code. Further, by focusing on thin slices of work within the feature, this helps to ensure that everything in the feature is added. Now, especially when combined with pair programming, right? Because of talked about that, a couple of months ago, where someone, is keeping the acceptance criteria in mind for the work in flight. And again, this improves confidence in the code being delivered. Now in the TDD we're going to talk about today, we're going to focus on unit tests. Code is going to be written and tested in small units independently, both in practice and, we'll be doing unit test TDD here. Now, this focuses on a consumable interface early on of independent pieces, and this helps us ensure the code is modular, extensible, and flexible. Modularity and flexibility are really important in the context of lean code. In practicing lean code, we often wait for the design to emerge, and this will help prevent yagning. In other words, this will help prevent you ain't gonna need it, adding something that's not needed. To help prevent premature optimization and other artifacts of digital rot. Because the code is modular and flexible, we have confidence that we don't need to add all the things now. Oh my gosh. Somebody always wants to add all the things now. But instead of doing that now, we can focus on the minimum that is needed today. Software development is more valuable when it earns money sooner and spends money later. All right, so speaking of getting money sooner and spending it later. So how is delivery speed improved? This is not magic. You can think of and maybe been on a team where sacrifices to quality were made and the team did legitimately move faster because code quality was sacrificed. While this can happen, this development ethos is not sustainable. Sooner or later, the tech debt will need to be paid. Speed will slow because of it. Code quality improvements also improve delivery speed over the long run. As the code quality improves, developers are free to spend relatively more of their time working on features. When compared to the opportunity cost of those same devs having to take on the time to work on tech debt of some form, maybe there's bugs escaping the team, or maybe the feature velocity has ground to a halt because the code itself is not extensible. TDD code is built incrementally, i.e. iteratively. Therefore, it naturally should be lean. It should contain the minimum amount of code to meet the features that were promised in the delivery. Lean code is easier to understand, maintain, and test simply because there's less of it. TDD enables continuous delivery because the code has been developed and is tested in isolation from its external dependencies. It can be tested and released independently. I think it bears repeating. Stable code frees up developers to add features when the opportunity cost is having those same devs working on tech debt of some fashion. All right, so how are we going to write tests? How do we write great tests? Great tests should focus on testing the behavior, not the implementation. Let's talk about what we are testing for just a moment. Great tests are going to be testing a unit of code. That unit should be the public API or interface of the unit under test. A great unit test is not going to test the private methods that the public API might call. Other examples to avoid in unit tests, testing the args that you pass into a mock or an external, you might be mocking an external service, and like some folks like to test those arguments that are being passed in. I really think we need to avoid doing these things because when we test these details of the implementation, we couple the test to the implementation detail. What's going to happen when later we change the implementation details through a refactor? If we're talking about great tests so that we can TDD, and if TDD is part of iterating through it, iteratively making great software, then we need to write it in such a manner that we can make changes to it without breaking tests, or at least that's the goal. And great tests, so that's why we really have got to avoid coupling tests to implementation details. Furthermore, great tests should clearly pass or fail. The result of the test should be a Boolean. Test should either pass or fail. The terminal or IDE should tell me N number of tests passed, X number of tests failed. I should not have to think about nor interpret the results of running tests. I don't want to spend mental effort understanding test results. They should tell me directly where the software is working as expected without me having to interpret it. Great tests do not contain loops, conditionals, or branches. Assertions are okay and they're required, but these other structures make test results and the tests themselves difficult to understand. This violates that a test should clearly pass or fail. Further, when a test fails, it should clearly tell me how it fails, that some result was expected and another result instead. Like when I start seeing branches and looping, a lot of times we're not being kind to our future selves when we start adding these structures inside of our tests. Great tests should pass or fail independently of other tests. If you need to run a test to set up for another test, I'm gonna have questions. We need to try and rewrite or factor your tests so they don't depend on each other. They should be able to run in parallel in any order. We are going to be running our tests over and over, dozens if not hundreds of times a day. If they can be ran in parallel, we're going to be more productive. Also, great tests should have a structure: arrange, act, assert. In the arrange step, you set up for your test. In the act step, you perform some type of stimulus on the unit under test. Then in the assert step, you verify that the response from the unit was as expected. Okay, I'm going to pause here for a moment to read the comment here in chat. Overly coupling test to implementation means that the hidden parts are now exposed. Yes, Thus, making any change, internal only or externally facing, means that the tests break. This is an anti-pattern, yes, and is often used as an argument against TDD when it's actually an argument against not degrade tests. Yes, well said. Well said, Michael. All right, so let's talk about like actually doing TDD, right? Like, how do we actually do this? All right, now, a lot of times, when folks talk about TDD or introduce TDD, and really, I'm not sure what I'm doing here. I don't know if I'm introducing it as something new or if we've been doing it like for a while. But a lot of times, TDD practitioners talked about the red-green refactor cycle. So let's talk about this. I add a step called think. Thinking is usually a good idea. I highly recommend it. And so, okay, so the story goes, right, is that the first thing to do in the TDD cycle is you start by writing a failing test. And then you want to make sure that it fails for the right reason. For example, make sure that it failed because the assertion was expecting a 17 and instead got a 23. Like this is really important. This makes sure that we are that when we do go green, that we also go green for the right reason. This helps us make sure that our tests are meaningful. All right, so we've written a failing test. We've ensured that it fails for the right reason. Then the next thing to do is the green step, and that is the simplest thing to make it pass. Simplest thing. Write some gangster code here, folks. Flashes of brilliance. Don't get too hung up on that now and try to implement all the things, right? Like I was saying earlier, test-driven development is about working on and delivering code incrementally, right? So when that test is red, make it green, the fastest way possible, the simplest way possible. Get to green quickly. And then once it's green, then you can make it right. Now, keep in mind that there's nothing necessarily wrong with not doing a refactor in the refactor step, right? Refactoring is not necessarily an obligation to do every time through the cycle. And a lot of times, and you'll see me in the demo that I do here in a little bit, a lot of times I purposefully avoid refactoring even when the pattern I think has emerged, because I want to make sure that the pattern that I'm going after is really going to solve the problem. So now let's talk a little bit about this think step. In practice, there's a few things to think about. Perhaps we're not starting anew. Perhaps we're adding a behavior to an existing class or method. Now, when this is the case, there's often work that I need to do a refactor before I can add additional behaviors, right? So I like to think about, if I'm working in a new code base, I like to take a few moments and kind of look through things and see how it's set up, and then ask myself, okay, given that I've got to add this, this behavior, how should I do that? And is the code ready for me to do that? Right? I mean, arguably, if it was written with incremental development in mind, it may not be ready for me to add anything. So I need to take a few moments to make sure that the code is ready for me to operate. All right, so there's a few, in TDD, right? A lot of times I find myself, okay, I've got some code here. Now what do I do next? Right. Well, there's three approaches tend to fall. The next few approaches tend to fall into like 1 to 3 categories. Fake it. Do something gangster. Do something that won't scale well. Maybe you just add a conditional and move on. The other thing to do is the obvious implementation, right? Like if you have a solution in mind, just do it. You have to be careful here with this one though, right? Before, keep in mind and be asking yourself, okay, I've got this solution in mind. Do I have the test coverage in place? Because if the test coverage isn't in place, then maybe there's some more tests that I need to add before I do the obvious implementation. And then the third thing is triangulation. I do this when I'm feeling stuck. Like, okay, I'm not really quite sure what's going on here. I'm not sure the pattern has emerged. or maybe I see a pattern, but maybe it's a false pattern. I'll add another test. All right. So the first demo, I think we're ready for the first demo. All right. TDD Basics. So we're just going to do a real quick demo of the Roman numeral kata. So give me just a moment here. I'm going to switch over to my IDE. All right. So, okay, I lost chat. Let's see if I can bring chat back. All right, wonderful. All right, ready to go. Hopefully you are looking at IntelliJ with a terminal on the bottom, an empty converter class on the left, and an empty converter test class on the right. This looks like a starting point to me for our Roman numeral kata. It's going to take in a number, and it's going to take in an Arabic number. It's going to output the corresponding Roman numeral. All right. Start off with the old test annotation. This is in Kotlin, by the way, and I'm going to write these as BDDs just to highlight, or I'm writing these as gherkins just to highlight that we're after behaviors here. I'm not gonna get too hung up on it and focus on it any more than I already have. All right, so given, and it's my own convention. I like to be clear about what method it is that we're testing. So I'm going to go given to Roman numeral because we're looking at a test class on the right operating on a test class on the left. And if I build out additional methods, or it may not be clear which public method it is that I'm testing. So I'm going to spell it out right here in the given. All right, given to Roman numeral when 1, then I. All right. Now I'm going to start by writing the assertion first. I found if I do this, it helps keep my tests leaner too. It helps me focus on the minimal test. All right, it's going to have a result, and I'm using the assertions is equal to 2. All right, now we said then 1 or then I, so this should be an I. So now I've got a broken result. I'm going to fix my broken result. I think eventually I'm going to have a converter object. And when that converter object grows up, it's going to have a 2 Roman numeral method on it, and it's going to take in a 1 according to my test up there. Now we need to new up a converter. All right, this is sad. This is sad. It's making me sad. It's red. I mean, I can run it, right? A compilation failure is a test failure. And it's cryptic. I'm gonna follow the prompts from IntelliJ. All right, so yeah, we're adding that 2 Roman numeral method there. It's gonna take in a number. I want it to be an int. It's gonna return a string. And then because IntelliJ, it's going to add this to do that. All right. All right, it appears that I fixed my test, but still complaining about something. So the operation is not yet implemented. Okay. Now, if my IDE finds this to do offensive, and so do I. Now, I'm not actually going to fix it to make the test pass because, like, in my mind, I'm still wrestling with the innards of the compiler and Kotlin and things. And like, I just want to get this in my mind. I have not encountered an appropriately failing test. The test is failing because of the inner workings of the compiler and the language and all that fun stuff. It's not failing because it does the wrong behavior. And I want to be very clear before I add any production code on the left that fixes the test, that that test actually fulfills my, it actually tests the behavior that I'm about to inject into it on the left. All right. And I'm looking down here and I see that, oh, it expected I, and I got an empty string. So yeah, so now what's the simplest thing we can do? I like simplicity. I'm just gonna make this an I, and I'm gonna run this. Okay, test pass, easy day. Let's come up here, and I'm just gonna copy and paste and just go down this line by line here in the interest of time. When two, then return double I. I still need a new converter object, so I'm gonna put in a 2, and then look at double I. Okay, good. I just ran my tests. It expected I, but I got an I back. All right, so what's the simplest thing that I can do here? I just noticed that I've got like a spelling error there. Oh, I'm gonna get to green first because I'm like serious about getting to green first. 2 equals number turn double I. All right, I'm green. Now I can actually come in here, make this a number. Easy day, can run my test again. Like even though I did it through the IDE, I don't trust it. I want to see these tests. I want to see these tests run. Like, and I'm still doing some triangulation. Like to me, it's like I really have not seen the pattern emerge yet of what's going on here. Uh-oh. Deleted a banana. All right. So yeah, 2 Roman numeral, then 3, then 3 for triple I. Can run my tests. All right. Yeah, we expected triple I and got back an actual I. Simplest thing to make this pass. Okay. I'm starting to see a pattern, but I don't know, right? This could be like a false pattern, right? So I'm going to add one more test. Let's go after 4, right? From 4, then Ivy. Chat's in the way. Let's go Ivy. Let's run the thing. Expected IV, and I got an actual I. All right. Okay. All right. So this does something different here, but this gives me some confidence that I'm starting to see a pattern here. All right. So now, okay. So now let's maybe look at, because I think we've got a pattern here, right? You know, for every one that is input, right, output and I. So right, so input 1 I, 2 double I, 3 triple I, right? So let's change that, but let's do this. I'm going to be very purposeful here. I'm going to do this in an incremental way. I'm going to add let's add a private variable called numeral, and let's set that to empty string. No, let's set that to I. And I'm going to come down here, and maybe you already see where I'm going with this, right? But I'm just going to add it like right there and just see if that works. Okay, cool, that works. All right, now, now what can I do with this? Well, let's see. Simpler, what is another, like based on what I have, what is a simple thing that I could do here? Oh, well, a simple thing that I can do here, right, is I can go numeral plus equals I, or plus I. Can I return that? I sure can. And so maybe I can come up in here and I can go plus double I. Can I do that? Okay, cool. Now, not going to do anything with 4. In my mind, that's outside the pattern. Not going to touch it. I'm like, okay, what can I do next? Well, I have kind of an idea of where I want to go with this. Like I'm envisioning, like in my head, I'm envisioning a while loop that operates on some kind of like remainer, some remaining value. So we'll do that here, but I'm not going to jump to that while loop. I'm not going to jump to that while loop like right away, right? I'm still testing this idea. I'm still testing this idea. And I'm thinking, well, my goodness, this isn't a lot of whole. This isn't while this isn't a whole lot of code to hold in my head now. Imagine if I was working on something big, right? Because like one of the values of XP, right, or one of the principles of XP, right? A self-similarity. If I get good at making like little small incremental changes on tiny little code like this, then I should, and I get really good at that, then hopefully that helps me get, that helps me be prepared to make little small changes to big pieces of code, right? That's that, right? That's that self-similarity principle at work in XP. So coming back to this, what does all of that mean here? What if, we do a reassignment here, right? Because I don't, when this grows up, like I really don't care, because I want to introduce into the conditional, I don't want to use number. I want you to start using this other thing that I'm working on. Okay, now, okay. So now what if I did this then? What if I said, this now uses remaining 3, what if this didn't return? What if this was plus I, right? And then what if this decremented that? And this should probably be plus equals. I'm not sure if this is going to work. I mean, I can find out. Okay, good. That works. All right, cool. So now let's do this. We can now, I can now get rid of this return that I have just been finding rather offensive. Will this work? All right. You know what? I'm live here. I don't want to think about it too much. I'm going to get back to green. All right. So this is the pattern that I'm after, like right in here, right? Oh, I think I know. I think I know. I think I know. All right, I'm gonna try this one more time. This is what time boxing looks like. I'm just gonna try this one more time, and if this doesn't work the way that I want it to work, I'm going to make that bigger change that I wanted. Oh, it's out of control. What's happening here? I 53, it's actually 2. I think it's missing this. So think about that. Okay. Let's go back here. Maybe a little farther. All right. This is a little bit of a bigger change than I wanted to make, but that's okay. We'll give this a shot. I'm going to introduce a while loop here. A while remaining, because this is me honoring that box that I put myself in earlier. I can go, okay, while remaining is in this, do this. I'm just going to comment that out for now. All right, we're green. All right. So yeah, so this is a little bit, I would say that this is a little bit better. There's still this early exit here if it's a 4, but we're far from done yet. And I figure we could either watch me maybe in the next 20 minutes or so, finish out the Roman numeral coda, or we can go back and chat a little bit more about iterative development. I'd like to go back and chat a little bit more about iterative development. So I'm going to stop sharing this and I'm going to go back to sharing some slides. All right, we should be looking at some slides. And again, I've lost chat. Wrong one. Let's bring chat back. All right. Let's talk about iterative development, right? Because if I were to stop now, we've only told half the story of TDD. Because testing is really, don't let the title fool you, right? Testing is only half the story. Let's talk about that iterative development piece. All right. Iterative development to me is about getting comfortable with being uncomfortable. Add behaviors via tests that add behaviors in small steps. Be constantly asking yourself, what is the simplest thing I can do that will work? In this way, we deliver the simplest code that we can that still works. In other words, the code is no more complicated than it need be to solve the problem. This means, and I alluded, and I mentioned it earlier, right? When I talked about that think step, this means that it may or not be extensible nor scalable past the need at hand. And that is okay. Iterative development is about delivering working software now. It is about recognizing the time value of money. It is about recognizing that someone has to pay for all of this. And that the code that I write is more valuable when it earns money sooner and spends money later. That is not to say that software never should be designed to scale and be extensible. Rather, it should be designed to do the things in relation to the business needs or the business direction now. And another bit on iterative development, as the saying goes, to make a big change, first make the change easy, then make the easy change. Warning, step one might be difficult. In my opinion, there is nothing inherently wrong with pushing out a big change, that is, waiting to make a big change until it is needed. Working with lean code has its advantages, less to understand, less to test, less to go wrong, etc. This could mean that at some point you're going to have to make that big change that you've been responsibly putting off making, likely due to business reasons. I'm not here to cast aspersions on our friends in business. To the contrary, I'm here to give devs permission to meet business needs and not go all engineer on something for its own sake. That said, at some point you have to pay the piper. You are going to need to get your hands dirty and make a big change. I'm here to tell you not to do that. Don't make the big change. Instead, take advantage of the nice test suite that you just wrote and make a series of small changes with the goal of staying green. Make a series of small changes until that big change is just really another small change. In this way, there is no big change, also known as a rewrite. Instead, there's a series of small changes. Okay, I'm excited. I'm excited. Like we get to do it. Like we get to do a little bit of Gilded Rose here, folks, and this is going to be fun. Now, for those of you that don't know Gilded Rose, all right, let's have a look at Gilded Rose. I'm going to stop sharing, and I'm going to share. There, and I'm going to pull back. All right, so here we go. Gilded Rose in 20 minutes. I'm going to wager that I can add conjured item. This is where this is going. I am going to add conjured item before we're done here today, folks. And I will argue that I'm going to do it responsibly. Let's have a quick chat about what Gilded Rose is. All right, so Gilded Rose. So the Gilded Rose kata, right? The setup for it is that you have this online shop. Gilded Rose, in my mind, it's probably it's an homage to the Gilded Rose shop in Stormwind in World of Warcraft, right? And the idea is that they sell stuff, and the stuff that they have degrades over time, right? Or some things like aged breed, depending on what the item is, it might increase in value. Some of the items have rather complicated Some of the items have rather complicated business rules, right? And the kata starts with you've got this stuff on the left is a starting point, right? And that's the unit under test over here on the left. And we have a very sad failing, I'll run this test. We have this very sad failing test. It doesn't even for the right reason. This test, in my opinion, is nonsense. Like, why even, right? So this is our start. All of this to say this is our starting point, right? And let's go back to the scenario because we're going to add some, we're going to add and modify the code on the left. And let's have a quick little chat about the scenario here. Oh my goodness, I'm burning up more time. Am I ever going to get to add contra item? All right. So here's the scenario, and I'm sure this has never happened to anyone. You just finished up your sprint. You just finished all your work for your sprint. It's done. Easy day. Another sprint in the bag, so to say. And then the PO wanders into the team space, knowing that there's just some amount of time. Let's say half an hour left in the day. It says, you know what, we really, our mage figured out how to conjure items. We have a what's the trend? Buy local, right? So we've got to deal with this mage here locally, and we want to sell the conjured item from this mage. But here's the thing, is the degradation rules around these conjured items, they're a little bit different, right? They degrade twice as fast as a normal item. So whatever a normal item does degrades twice as fast. And the PO says, I really, really got to have this. And say, okay, well, but here's the deal, right? The existing code that you've already seen, it commits various sins. On the other hand, it's in production. It's been in production for years, let's say. And let's say there's no bugs filed against it. It's a productive member of society for years. And after chatting a little bit with the PO, they say, yeah, we are going to have some additional business rules here. We're gonna expand out into beverages and things. We've been selling beverages, but we haven't been really tracking them the way that we should. And we think we're missing out with the pig and whistle is taking away from our beverage. But we can live with that for a couple, but the PO says, you know what, we can live with that. We'll get to that in a later sprint, but I really, really got to have concert item today, yo. All right. So you've seen, and let's go back. Okay, so now we're back in Gilded Rose, right? And so we need to add a conjured item to it, right? And we only have a few minutes to do this. How can we responsibly do this? How can we responsibly do this, right? What would you do if you needed to add conjured item to this? What would you do? What would you do? Well, here's what I'm going to do. I would say that, well, as offensive as I find this stuff over here on the left to be, it's in production. Gilded Rose has made a whole bunch of money off of this code for however it offends me. It's a productive member of society. So, and the business is telling me they want conjured item today. Well, let's do conjured item today. How can we do conjured item today? All right. Well, let's see. Let's see how far we can get here in the next few minutes. Actually, I don't want to. I'll even keep this. All right, given conjured item. When let's do something trivial, just to start off with. Selling. When let's go not expired. Then one. All right. We're newing up our item here. Let's go conjured item. And then here, item 0, name. This doesn't make any sense. Sell in. All right, sell in, and I want this to be not expired. So sell in has to be 1, moving some things around on my screen so that I can see. Okay, good. Quality 0, that seems risky. We'll move quality 10, decrement that down to 0. So I think this makes sense, right? A sell in of 1 is not expired, decrement by 1. Oh, easy day. I get that one for free. Yay. All right, so let's do this here. We're gonna go if conjured item. What I'm doing is I want to create a theme here. I want to create a spot where I can operate and do some work and not have to worry about what the rest of this application is doing. Dot name, right? And then here I can just return. Maybe. Yeah. Perhaps earlier, right? I was relying on the existing code to do the decrementing, right? Now that I have my area working, my test was filling a much needed purpose. Okay, good. When not expired. And then, so one of the things I'd like to do here, let's check the boundary condition, right? Because what it does not expired is pretty clear. What it does expired is pretty clear. What about expiration day, right? Let's make sure that we test, all of our boundary conditions. And let's say, and it's still going to decrement by 1, right? So, but expiration day has a sell in of 0, and then this thingy. Now I'm going to leave this. Writing character. Arguably, what I'm doing now is a characterize. No, I'm not actually. This is not a characterization test. I'm getting lost in my own head. All right, it works. This is green, but like I just wrote this test and it just so happened to pass. So, like I want to see it fail, and I start with. I just want to see it fail, and then even though the test is wrong, right? But I can look at this and go, yeah, it was actually -1. It started with 0, so the code is actually doing what I wanted it to do. It's this test that needs to change. All right. And then when expired, then decrement by 1, not expired. Two. Okay. All right. So it's getting late, and I'm going to take a little. But you could probably imagine at this point, right? Where I'll do one more. I will do one more just to. Just to kind of finish, just to sketch out what's going on here, right? So let's go when, yeah, and let's when expired, then decrement, and oh, those all. Now we want to go after quality. Earlier we were going by sell in, probably was not clear what all I was working on. So now, see, when we're expired, our sell in is -1. We can keep quality 10. Need to change this to quality. And then it degrades twice as fast as a normal item. Normal item degrades by 1. So this would have to degrade by 2, so it goes to 8. Bam. All right. Expected 8, but it was 10. All right. So here, let's put it up here. And if, actually, I don't even need an if. Items by quality minus 2. All right, green. We're green. Now, in the last few, now I haven't really shown, but you at this point, you could probably imagine like what I'm going to do next, right? So now let me clear this up a little bit. I want to try a little bit. I want to like at least take a few minutes to like show you a way to iteratively work on gilded rows without doing a rewrite. All right, give me just a moment here. Give me just a moment here. I have some work in another branch. All right. Previously, I've come through here and I added a whole bunch of tests, and I finished out conjured item. All right, cool. All right, so now, let's now, right? So now, we're now a couple sprints ahead. Let's pretend, right? Now conjured item has been out in the wild for a while, right? And so now like we're a couple sprints ahead, and then we need to add like, rules for like beverages, right? So then, now what do we do? Well, we know that this stuff over here is like on the left is just not good stuff. It's difficult to understand. It's difficult to scale, right? So how would we go about making changes to this? All right. So what I like to do is first just run all the tests, even though I just did. All right. So what I like to do is I like to make tiny, little small changes, but over time, these pile up. I can come in here and I'm just going to do something just a bit innocuous. I'm going to lift out these knots. I'm going to put, for parens or bananas, you might hear me call them burn. Put bananas around this thing. I'm going to lift that out. I made a change, going to run tests. All right, it's 3. And then I'm going to come in here. Lift this out. Now, I may not have enough time to actually go everywhere that I wanted to do. Uh-oh, something failed. No worries. I can put that back. All right. I started going after aged brie. So everywhere that I see aged brie, I'm going to do a thin slice within a slice just to kind of show how I operate here. Or at least how I do this. Away, I should say. It's not make that change so big. Okay, good. I think I've identified all the places where we're checking equality on aged brie. So I'm going to extract the method and just call this thing is aged brie. And my ID is telling me it's in other places, and yes, do that everywhere. So now I'm starting to understand. So now I've got a way, and I can continue along this path, building this out, right? I see we're doing another comparison to sulfuros or sulfurous. Pull this out. Here. And my test. Okay, I can continue to do this, right? And some other things that I can continue to do. So like imagine, I don't really have running out of time here, right? I can go through, I can extract methods and all of these checks. If I can call them is aged brie, is backstage passes, is sulfurous, right? And then I can come in here, I can go, oh, I've got some nice logic here. And this looks to me like this is what a safe decrement, safe decrement quality. It says there's others. Yeah, that looks like a nice spot to use it, sure. This is a nice spot to use it, sure. And then I'm gonna run my test again. And then so now, all right, and then so now you can imagine that what I'm doing, right, is I'm building up I am, begin to build up methods down here, and then you can like move, these little helper methods, right? Um, and as you look through this, you can see that you can actually move some of the conditionals around, and you'll find, oh yeah, I now have, um, because I've moved a conditional around to an equal spot, I'm now at a spot where I can use my private method. And you keep after it, and you keep after it, and you keep doing that. And you're running and run tests like all the time, right? Let me switch to another branch. What did I call it? Oh dear. Is this first refactor or second refactor? Let's go first refactor. Here we go. All right. So here is the final solution, if there ever is such a thing, right? And so what we have here, right, is we have some kind of factory, and we're going to new it up in here, and then depending, and then that factory is going to create some kind of item, right? Depending on the name. I kind of don't like my abstraction here now. I'm passing in, I'm passing in the entire item. I want to stop what I'm doing now and refactor this, because arguably the factory, well, maybe the factory should know about the entire name, like maybe it shouldn't. Arguably, I have the wrong interface here. But at any rate, for now, this is what being comfortable, this is what getting comfortable being uncomfortable looks like. But like, right now, depending on what that name is, right, we're going to new up some rules. And then, right, so for example, in H3, if you watched me like do this, all of those like private methods that I extracted, I'm now going to re-inline them into, in a sense, right, into these classes that are the rules for these various items. Right now, if we have time, we don't have time, just gonna ask you to trust me. Like you can imagine, and there's probably some folks that have done this here too, right? Like you can actually like go through what that was, extract out methods or something, somehow simplify it, make it easier to reason through, and then use those same bits of code and then put them into new things. Something that I like to do is, while this interface is external to this Gilded Rose class, at one point it wasn't. At one point, all of these things you see that are inside of the shop item package were actually sitting right here, right? And then I extracted them. And did I write tests for them? No, I didn't write tests for them, because this comes back to something that I talked about early on, right? Is if I were to arguably, because I have Gilded Rose tested here, I don't need to test those because I'm testing an implementation. The tests that I originally wrote as part of Legacy Rescue to Gilded Rose are sufficient to cover these classes. Now, we could argue about and have discussions. Well, now what happens then if these shop item tests? What happens if these shop item classes that have the rules, what if those are somehow consumed externally outside of Gilded Rose? I would say not a now concern, right? I mean, maybe. I mean, let's go have a chat with our PO and like talk about what's on the roadmap for the future, right? All right, so I'm going to stop talking about code here because we're way close to the end. I hope, like I said, I wish I had more time to like go through the various steps, but let's bring it back maybe to the presentation, and let's wrap up the presentation. All right, we covered three things today: the benefits of TDD, how to write great tests, and how to write code using test-driven development. Thank you for your time. We have a few minutes here yet. I'm going to hang out and look at chat and see if anybody has any questions. So thanks again for your time today.